life. Up top, drop top, baby, it's a no-brainer. Put them up if you with me.
Hi everyone, I am A. Bugas from grade 11 Mount Pulag, and this is actually my first video tutorial about PMI, or Principle of Mathematical Induction. So PMI is a technique for proving a statement, a proposition, a theorem, or a formula that is asserted about every natural number. So there are actually two steps in PMI. The first step is we first establish that the proposition of P of n is true for the lowest possible integer n. And the second step is we assume that P of k is true and establish that P of k plus 1 is also true. So now let us prove 1 squared plus 2 squared plus 3 squared plus all the way up to n squared is equal to n times n plus 1 times 2n plus 1 over 6 by using PMI. So the first thing we need to do is let n be equal to 1. So this is the left hand side while this is the right hand side. Let the left hand side and the right hand side be true. So for the left hand side, we use the first term, which is 1 squared. And for the right side, we substitute n by 1. So it would be 1 times 1 plus 1 times 2 times 1 plus 1 over 6. So 1 squared is 1. 1 plus 1 is 2 times 1 is 2 times 2 times 1 is 2 plus 1 is 3 over 6. So 1 is equal to 2 times 3 is 6 over 6, then 1 is equal to 1. So therefore, it is true. So for the next step, we assume that P of k is true. So copy the equation 1 squared plus 2 squared plus 3 squared plus dot 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 plus substitute the n by k, so it becomes k squared is equal to k times k plus 1 times 2k plus 1 over 6. Then the next step is to show that P of k plus 1 is also true. Just like before, copy the equation, then substitute n by k plus 1. So 1 squared plus 2 squared plus 3 squared plus dot 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 plus k plus 1 squared is equal to k plus 1 times k plus 1 plus 1 times 2 times k plus 1 plus 1 over 6. So this just combine or multiply. So this becomes k plus 1 k plus 2 times 2k plus 2 plus 1 over 6. This becomes k plus 1 times k plus 2 times 2k plus 3 over 6. So we assume here that this is true, and then we showed here that this is also true. So we need this to become like this. So take note that before k plus 1 squared, there is a term k squared. So 1 squared plus 2 squared plus 3 squared plus dot 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 plus k squared. As I've said, we need this to become like this, so we just need to add k plus 1 squared here. So plus k plus 1 squared. So for the right side, since we added k plus 1 squared to the left side, we should also add k plus 1 squared to the right side. So k times k plus 1 times 2k plus 1 over 6 plus k plus 1 squared. So as I've said, we need this to become like this. So this is over 1. Find the LCD, verse 6. So 6 divided by 6 is 1, then multiply to this, so it becomes k times k plus 1 times 2k plus 1 plus 6 divided by 1 is 6. Multiply by k plus 1 squared is 6 times k plus 1 squared. Then multiply, it becomes k squared plus k times 2k plus 1 plus 6, expand, k squared plus 2k plus 1 over 6. And then we need to multiply k squared plus k to 2k plus 1, then multiply 6 to k squared plus 2k plus 1. So it becomes 2k cubed plus 2k squared plus k squared plus k plus 6k squared plus 12k plus 6 over 6. Then combined similar terms, so 2k cubed plus 9k squared plus 13k plus 6 over 6. So if you factor this out, this becomes k plus 1 times k plus 2 times 2k plus 3 over 6. As you can see, this is the same. The right hand side is the same, while the left hand side is also the same. So therefore, thus, p of k plus 1 is true. Therefore, 1 squared plus 2 squared plus 3 squared plus ... plus n squared is equal to n times n plus 1 times 2n plus 1 over 6. End of proof.
Pop top, drop top, baby, it's a no-brainer. Put 'em up.